I did start streaming, so it should be up.
Okay. Well, hopefully it'll come through in a moment, but
give
it has
me a
not come
second.
through for me
Let
yet.
me just try this again.
It has not come through for me either.
Okay, let me try this again. Oh, right. Okay, let me repeat myself. It looked like it took a little delay.
It just started though.
Okay.
Okay.
Oh,
sorry.
there it is. Yes.
Welcome to another episode of Common Lisp Study Group. We have with us Jackdaniel, who is going to give us a nice overview of McCLIM, the Lisp GUI Toolkit for writing user interfaces and applications. Before we get started, because I don't want to take too much time here, I just want to mention to folks who are watching the YouTube live stream that please post your questions, and we'll get to them as quickly as possible on the YouTube live stream. So, and for folks who are joining us in the chat, if you can allow the presenter some time to complete a particular thought, it'll probably help drive discussions and questions as we go along. So, without further ado, Jackdaniel, please take it away.
Okay. Hey, my name is Daniel, and I'm maintaining McCLIM. I've decided to make this geeky presentation in org mode for you. So this is based on notes I've shared somewhere on the internet. I will share my screen, and we'll tell you something about CLIM. So let's start with some historical perspective, because CLIM, Common Lisp Interface Manager, was invented by Symbolics, then adapted by different systems, and it utilizes technologies which are much older, most notably presentations and General Dynamic Windows. General Dynamic Windows was direct ancestor of CLIM, and presentations were not really related to Lisp, but they originated at it. Presentation is a semantic link between application data and something what you can see on the screen. And in 2000, Mike McDonald's has created free common Lisp Interface Manager implementation, which is called McCLIM. Over the years, it had its ups and downs regarding development, some periods of stagnation, some of active development. And right now, we are at active development of it, and we are regaining user base mind share between the Lisp community. And we have a community. If you want to learn about McCLIM, the most prominent place to start is its website. Then we have repository, tracker. If you want to have some questions addressed, just join the IRS channel. And here is specification. Specification is something what was developed by Symbolics, and it is part of repository. On the internet, you may find annotated version hosted by Gilbert Bauman. He was one of the contributors to McCLIM, and it contains a lot of specification, but you can't treat it as documentation. CLIM is a lot of protocols which are developed to make it easier to use at different levels of abstraction. I will get to it later. And we have a bounty program. So if you want to get some money, you may just see which issues have bounty assigned to them. And if you solve the issue, you will get the reward. Rewards are somewhere between $100 to $1,000. And we have a steady stream of funds coming from the community at level of $300 a month. So we can set a big chunk of bounties every month. We are not adding lately new ones because we still have others which need to be solved, and we don't want to create a chaos. So as I said, CLIM, as you can see here, there is geometry substrate, windowing substrate, sheets, mediums, extended streams. It is a lot of information to process, but what we are interested in are high-level concepts, and it is read command, execute command, display loop. It is similar to read eval print loop. You read a command, execute it, display the window, and go over again. But what is a command? Commands are similar to functions, but they are parsed interactively. So they are something what is presented to the end user of your application. Like you may say show direct. It is similar to bash show. You have commands like ls for listing or make directory. Commands have arguments which are specialized on presentations. So maybe I will show it. So Team Examples is a system which contains our demos, which has some let's say German towns. This application, and when we click here, a command is executed. Show town info Berlin. We may type it, show time info, and we have a question, which town? So we invoke a command. It is direct parsing, and we select a town about which we want to know something about. And these red circles are presented objects which have direct representation in the application. And we may have different objects presented on the screen, but presentations are typed, so I can select only towns. So this will do for simple presentation what is a command. And let's talk about the display. Display is not the same thing as repainting things on a screen because in McCLIM, every object has its identity. When you display, you create output record hierarchy. And when you draw a rectangle, you have output record, which is representing this rectangle on the screen. So this is quite similar to DOM model of HTML. And when you repaint screen, because it is some part of it is damaged, then we just replay output records which overlap with damaged area. And presentations, much older idea, which was adapted in CLIM, are set semantic link between application data and what you see on a screen. This idea is not well understood, but it allows to create ontologies of objects. So applications which have nothing in common may adopt same presentation ontology, and then they will be able to interact with each other. Let's say you create a file manager, and then you create a PDF viewer. You explore your files, and you want to see one file in your PDF viewer. So you click in menu, open PDF, and files in the other application, which are presented, are something what is responsive to pointer input, because it is typed presentation on which open command specializes. So you may pick objects from different application if you know how to handle them. And this is system architecture. I will focus, CLIM is complicated, I will focus on low abstraction right now. Previously, we have talked about high-level concepts, RxDL loop, and now I will describe how the smaller low-level loop works, event loop. Okay, this is weird. Let's focus on process next event. Process next event is directly connected to your windowing system. It might be X11 server, it might be whatever is whatever is provided by the operating system, and we take events. Events might be keyboard input, pointer input, window has been moved, so operating system tells us that something has happened. When we so this works asynchronously in a loop. We process next events and we dispatch them. This part is not implemented yet. This is something what is planned as future improvement, but I will talk about it as if it were implemented. So we dispatch event and we queue this event in a thread safe queue. When we have a simple event loop, it looks for events and then handles them. Then handling events may invoke many operations. One of them is to populate stream abstraction input buffer. Input buffer allows us to parse commands. So when we read gesture, gesture is input event. So gesture is something what you do. You may move your mouse or you may press the key. And this is called by this higher level abstraction by parsing commands. We read gestures, and when we execute command, it calls redisplay. So now let's focus on repainting loop. It is not the same thing as displaying. It queues repaint. We have repaint loop, which repaints sheet and handles repaint. McCLIM provides drawing primitives, so you may draw rectangles, circles, you may draw anything, but also when we repaint something what has been already displayed, we call replay. And you may specialize each of these methods because this design is substrated. Maybe you have noticed that we have here red arrows. It is possible using abstractions defined in CLIM to create much simpler GUI toolkit than CLIM itself. And it is something what was explained in the paper called Reflecting Windowing System Silica, that you may use lower abstractions and you may opt into some higher level stuff, but you don't need to. CLIM is complex, that may cause that its performance may be worse than you need to, than you want to. So you may directly implement handle event from dispatch event and repaint sheet. And then nothing of this matters. So you may implement fast methods, which do something at real time. You don't even put it in the queue. So we'll get back to it if you will have questions. Mm-hmm. And now we'll do some live development. How to create simple CLIM application. We'll use just package CLIM user, which imports common list symbols and CLIM symbols. So I'm just being lazy. Normally, you would want to define your own package, of course. And we define application frame. Application frame is a top-level window, which is receptive to input and shows things on a screen. Define application frame is actually a defined class with extra options. So we may define here any slot we want, like color, and we may define panes. Each panes are windows which are part of the frame. So we may we may have multiple panes on our screen. Some of them might be streams, and we may intermix basic panes which are not very creamy, but they will work as something defined in lower abstraction levels. So let's define one pane which will be application pane. And interactor pane. And we may define layout of our application. We may have multiple layouts, so we may have debug console for developer. So developer layout has different tools and something what is presented to the user without unnecessary clutter. Vertically. The name is layouts, not layout. That's good because here you will see what problems you may encounter when we define things. Okay, so we have this application frame and how to start it. Run frame top level, make application frame and test frame. It is empty input. We have nothing to do here. We may type help. For instance, with keyboard and input editor commands are like Emacs. So I may use Control A to get to the start of the line. So let's define a display function. Display function has two arguments, a frame and a stream on which we're going to draw. And for starters, let's draw a rectangle. Here you can see that it is specialized on sheet. Sheet is abstraction for window. Okay. We have two versions of draw rectangle. One works on points, and the other works on coordinates. Streams, clean streams, are also windows, so we may put it as argument. And we will use color from our frame, because these are normal slots. We didn't connect the display function with our stream. So we have here application, and we will set display function to display. And here we have wonderful square. As I said, this is normal class, so we may put here init args. It is called color, dark blue. And it is different. Now I will define a simple command which will specialize on a particular object. To make things more practical, we will display ASDF system for that. So I have mentioned presentations. Presentations are not like classes, are not like silos. They are like common Lisp type system. They may have parameters, they may have options. So we may have presentation integer from 0 to 5 and presentation integer from 10 to 25. And these are two different presentation types, while classes have very strict hierarchy. But of course, each class may have a presentation which doesn't have parameters. we'll define presentation method. Present, it is a standard presentation method. I won't go through how these things are through these abstractions, but I will focus just on getting things working. So presenting things is a method which allows us to draw on screen. There is also a standard method accept, which allows us to parse some input. In principle, you could define accept method which hooks into your microphone and waits until you tell the magic word, which gets parsed into some object. So we have object of type ASDF system. Okay. Stream, let's have it textual view right now. And how we will present this object. We'll just use standard function format to stream system and its name, or its non-readable representation object. Okay, and then our display function displays our rectangle, and we'll also present on the screen find system ASDF McCLIM, sorry. We have this system. It is printed, as you can see. We can intermix normal text operations on a stream with graphical output. We may position cursor, of course. So this is our system, and we may define commands which operate on ASDF systems. So let's define such command. Define test frame command. Each frame has its own command table. We can import command tables to application. We can define inspectors, which will allow to inspect objects which are on the screen. But right now we will create a command which shows system name. And it will be visible in the menu as well. So, as I have mentioned, arguments specialize on presentation types. This will be specialized on ASDF system because classes are automatically recognized as presentation types. And what we will do is that we'll print it on standard input. This may be counterintuitive, but application panes are bound to standard output, and interactor panes are bound to standard input. In this top level read command, execute command, display loop. We don't have system name here in the ASDF. Long name. Maybe this is what we want. Argument. Okay. So as you can see, it is not selectable, and we start parsing command, and we are looking for a system. And now we can select ASDF system. System of name nil. So there is no long name. Maybe we should call it short name. No. let's focus on system depends on. Once again, and here we have a list of systems on which it depends on. Now we'll focus on creating a dependency hierarchy between systems so we can display it. We'll have a command which will allow us to display systems which we depend on. And display function will change accordingly. McCLIM has many formatting functions which allow us to draw table.
The audio cut out?
Yeah, it looks like the audio cut out. Jack Daniel.
Looks like the video cut out too.
Yeah. I think he had a network connection issue.
I will message him on IRC.
Okay.
They might be looking for extended stream output facility. We have some root object.
Hey, sorry to interrupt, Daniel, but your last explanation, the video stream kind of froze from your end, so.
Yeah, we lost about the last minute of your talk.
Okay, it uses format from roots, so I will use that because I will have help the bottom.
Can you hear us, Jack?
ABC.
Hey, Jack.
B is not a list. Okay, so this is how it looks like.
Hey, Jack. Can you hear me?
Now we want to show a system which is actually a tree hierarchy in ASDF. So when we have a system, then we format it from root base system frame. Object printer will be print right now. And inferior producer will be ASDF system depends on. Okay, that just as I thought. System depends on produces strings, but accepts actually systems. So this is one of known problems, at least problems I'm aware of in ASDF, that it has some problems with parsing its own output. Okay, this is quite big, but here we have a graph of dependencies for McCLIM, from root to the leaves. We may take something simpler, like clim basic instead of McCLIM. That looks much better, and clim basic provides these lower abstractions, which I have talked about previously. We have border threads, some portability layers, closer mob, and that's it. So let's make it more interactive. We will, instead of printing things, we will present them. We will present them as ASDF systems. First, we will define our command. Define test frame command. Show system depths. Name team without menu. We will accept a string or maybe a system. Let's focus on string right now. And when we have the string, we'll just set base system of application frame. This is some dynamic context, because when we call command on this frame, then it will be bound to the frame we are talking about. Argument. Okay. Grab the system name. We accept string, but we'll present ASDF object. Doesn't work, of course. Because this will be called with a stream as a second argument. Because this may be a function defined elsewhere. We don't have necessarily a closure context into this stream. same problem as before. So we'll ignore flexi chain. So here we have system presentations. They are presented as we have defined them to be presented. Now I will focus on this argument, a view, because we, by default, present something on textual view, but we may have different views. So depending on the view of the stream, object will be presented differently. I will get back to this analogy from before, when we had file manager and we had PDF document viewer. So both were files, but on file manager we could see an icon and a name. But on PDF viewer we will see something totally different. We will see underlying document. So these things may be specialized on view, like PDF document view and file manager view. So we have this presentation ontology. We can present same objects of same presentation type differently depending on where we display it. Let's define our graphical view. Default view. We'll define constant for it. Okay. All right. And we'll create a separate method, present, which will show things differently on our application pane. This is another part of another operator which allows us formatting output. This looks like this. Maybe we can short it a little. Let's cheat a little, and I can't cheat.
Can you hear us now, by chance?
Okay, let's see, what does it do? It registers system definition with this name. Okay, never mind. I'm not a big fan of ASDF, to be honest. Okay, so Here we have this representation. To show you that same things may be presented on different streams and look differently, I will create second application pane, which will be shown side by side with this one. And the other one will have textual view as default one. Nothing will change. We will have the same display function. So, up to, sorry. Dwa is Polish word for two. Horizontally. We may add label, of course. And we see nothing. And I'm not sure why. Because same display function should be called for one and the other. Maybe we do not use stream. Okay, that's it. As you can see, here we have textual output and here we have graphical one. We may have function, we had function, which I have removed. Okay, I will create a new function. Show system, just show system. It will specialize on system object, format standard input.
Is it just me or is there no sound?
Invoke show system.
Might just be me.
And we may
It's just
pick one of these, one of these. So disregarding how they are displayed, this graphical input is typed input, so we can pick up things when we want them. All right. So I think that this should suffice for a sample demo for live coding. Maybe I will show some of existing demos to present some functionality. This is one of the older demos which were created in 2005, I think. But it looks nice because it is a game. This is a recent addition, word wrapping. So, and margins. We create margins and we wrap things by word. We may wrap page. It doesn't look nice, not very useful, but it is possible, of course. And as you can see, we have baseline, which grows depending how we format the output. This is another recent addition, clipboard. We can copy this presentation, which is integer. It is not a string. And paste it here, 35.
That's
so, or we can copy this image, paste it, and we have defined translator because we can provide presentation translators between different presentation types, like image to integer. So this image is clearly 42. And if we have figure, we copy it and we paste it. So we have figure glider because this is its type. When we pass it as image, then we don't have this caption. It has translator to integer. It doesn't have translator to float. And it has translator to string. So I think that this will be picked by Emacs. Exactly. So having clipboard working between X11 and McCLIM was inspired by Elias Martison, and it was added quite lately, a few weeks ago, I think.
Daniel?
Another one. So in this example, we say that print numbers before each line of text. We have it wrapped by word, and we print next line numbers. We print just vertical bars. If you're interested, it is all in a system called McCLIM examples. Demo. And I will show you one more thing. This was made to actually debug some part of mirroring. Mirror is a native window in display server, which is mirrored by a sheet. So we have this simple application, and we may change it from Lisp process. These windows here, these windows are presented here. We may do something like that. This inferior window is a child of pane 6. So when its parent is smaller than the window itself, then we don't see part of the output. Okay. So recent progress. Lately, we have implemented selection translators. They allow transforming between different pasting. If it works inside the same Lisp image, we may even copy-paste objects which are arbitrary, and it's not re-copy pasting. We just access the object, so there is no performance penalty for marshalling and demarshalling the object. Better text rendering. We have true type font rendering, and I have implemented a few months back kerning and transformations. Maybe I will show it. Text transformations. So we may transform text whatever we like. We have kerning. We don't have sub-pixel anti-aliasing. I'm not working on that. If anyone is interested, contributions are welcome, of course. I have shown you markings and word wrap. Right now, I'm working on improved drag and drop support. It works, but it could work better. And I'm re-implementing event queue. So the input buffer. Right now, event queue and input buffer are physically the same object. From abstraction point of view, they are separated, but the problem with current implementation is that functions like stream input wait directly hog on event queue. So I want to separate them. So gadgets are equivalents of widgets in other toolkits, and presentation and streams with presentations can be intermixed. Right now it is a little problematic. Markings and word wrap. So here is some roadmap. what we plan to. This is something what I'm thinking will be good for McCLIM, but this is a community project. So if you want to get involved and you think that something else is more important, and if you implement it yourself, and the contribution will be of good quality and it will pass the peer review, your own features may land in McCLIM before these things. This is my to-do, which I would like to implement at some point of time. So stream thread safety. We have the stream operations, but if we do it outside CLIM event loop, for instance from Slime REPL, it is not thread safe. We may corrupt output record hierarchy. Fixing that is actually easy because it's enough to define around methods around streams, which check if it is a CLIM process or something else, and if it is some else process, we just queue the event with these operations as lambda, which will be executed inside CLIM loop. So this is perfectly doable. Dragonstone substrate. I will focus on it a little. I have mentioned that this lower abstraction levels, especially this part, we have event, we may handle it, and we can repaint shit because we know what is damaged. They may be used without rest of McCLIM, and I think that separating these lower abstractions, which may be used into a separate system, which may be dependent on, will allow creating more graphical toolkits, because not everyone buys actually CLIM model. Presentations are great. I think that stream protocols are very useful, but not everyone thinks so. Somebody may want immediate graphical user interface like IM, GUI, or Nuclear, or people may want just to draw things and handle events, for instance, to write a game. So this part could be reused by many toolkits and backends, which are behind this process next event, could be shared between different applications which implement some abstraction to create graphical tools for Lisp. So this Dragonstone substrate would be a common foundation for many graphical toolkits for Lisp. That's my hope, and I want to try to convince people to write toolkits on top of Dragonstone, because shared effort would benefit all these toolkits. Repaint queue and animations. I have mentioned it before that this part is not implemented when we have dispatch repaint. It queues to event queue, and we handle events by calling repaint sheet. So this is the same thing. But I want to have it in a separate place. Thanks to that, redrawing things will be more robust, and that will enable another thing which I'm thinking about for quite a long time, namely animations. Animations having output record, which changes its graphical representation without redisplaying it over time.
What the fuck?
Xrounder migration. We have X11 core protocol. McCLIM uses CLX. Some parts are using Xrounder, but not all. We use primitives like draw arc or draw rectangle. But Xrounder is much faster and enables things like alpha blending, double buffering. So this will improve McCLIM performance, and things developed for this render extension could be shared between different backends. DPI, independent display. I have talked about it in a blog post which I made for McCLIM website. It is a project. treats as ideal forms. So here I discuss that applications should operate on physical sizes. So one window disregarding where we draw it will look the same. If you want to read it, I've put some work into it. I think it is something worth reading. I want to work on that because this will allow many cool things like this one, mapping applications from graphical perspective into the console. It looks ugly, but I think that this is usable, and this is even more useful. So let's console backend. This will be a toy example, but it will explore many edge cases, off by one errors. It will discover many off by one errors, and will be a great experience to actually guide how to write backends, because we'll have to go through each step to write it, and by discovering different edge cases which are not common between different toolkits, it will make it more complete. And portable reference backend. We have common questions. If can CLIM run on Windows? Well, it can if you install X11 server, but we want to migrate as reference backend because we may have many different backends in parallel. We want to migrate to something like SDL2, which works on Windows, Macintosh, on Android, of course Linux. And material design. Our default look and feel is quite dated. I have common complaints that it looks like mosaic. So implementing material design, which is really nice. I've read it, and this is something we want to have. So now I will go through some frequently asked questions. What is McCLIM licensed? It is not GPL, it is LGPL 2.1 or later option. So if you write your application with McCLIM, it doesn't affect your license because it is a library you use. Does it run on Wayland, Windows? It runs on each operating system which supports X11 display server. Windows has it, Wayland also has it. It is called X Wayland, OS X also. I think that there are some hacks for Android which install X server as well, but I can't tell for sure. If you want to write a new backend for your operating system or your display server, you can, but there is no documentation. We hope to wrap one when I will start working on console backend. Another question is why CLIM is so complicated, and people complain that they do not understand it. As you can see, specification is lengthy, and these are all protocols explained in details, but here we have mixed some low-level abstractions, higher-level abstractions, so it is all mangled together. And judging CLIM complexity based on that is like saying that CLOS is complicated, Common Lisp Object System, based on reading meta-object protocol, because CLOS is implemented using meta-object protocol. So this specification is a meta-object protocol for CLIM Common Lisp Interface Manager. This is all I wanted to say. So this is time for discussion, questions. Thank you for your attention.
Well, thanks for giving the presentation.
Can you hear us?
Sorry, I can't hear you. Hello?
Hello? Can you hear us now?
I had the same thing happen to me. I had to leave and rejoin.
He's going to rejoin. Just give us a second here. Hopefully, the opening for discussion. It's a
discussion is important.
Yes, and boy, do I have questions.
Well, I'm sure we'll have some interesting answers.
Yes.
See if he rejoins. Wait for it.
Hi, Daniel.
Hello.
Welcome back.
Oh, I've noticed that I didn't hear you at all. But did you hear me?
Yes.
Yes.
There was about a brief, maybe a minute where your connection dropped out.
Yeah, when you went hunting for the find graph from roots function in the source, your connection sputtered out. It came back again after a minute, and we could hear you after that. And so, we didn't miss any explanation. But,
okay.
You couldn't hear us after there, apparently.
So my first question is, what is the status of the material design?
Well, the status is that I have some hacks which are proof of concept, but nothing else. We don't have even guide how to write frame managers. It is a concept I didn't explain yet, but frame manager is responsible for picking concrete implementation of your pane or of your gadget for your application. So you may have different look and feels, and you may say that I'm using this frame manager which gives me material design, or I will use this old school McCLIM look. So it is not advanced at all. It is in purpose put as the last because there is nothing to share yet.
Okay.
I noticed that you were specifically specifying the layout in your application frame, and I noticed this in general. Is there a way to separate that out? I'm thinking of style sheets in Qt, where you separate the style sheet and the look and feel and its layout for different types of situations from the actual code itself. Is there any plans for that, or does it exist already in there? Or
well, in the past there was McCLIM application builder. I think that there is even an article on the internet how it looked like. Writing such tool shouldn't be hard, and you have all macro capabilities. We don't have resources right now to work on it, but if somebody just jumps in and creates such tool, it will be great.
Okay.
There is nothing technical what would prevent that, okay?
Okay.
But there is no effort in creating such tool at the moment.
Okay.
At least I'm not aware of it.
With regards to the backend, because I'm curious about implementing a backend myself, is there in the McCLIM specification, the hardest things is kind of weeding out, I guess, the protocols to build the backend itself from the high level API itself. Have there been efforts to try and separate those two, working efforts?
I have talked about it. This Dragonstone substrate would separate low-level abstraction from high-level. And with that, I'd like to have actually documentation how to write backend, how to use it, so we can have proliferating ecosystem of different GUI toolkits using the same abstraction, same backends.
Yeah,
so
I saw.
This is.
Sorry to interrupt. I just wanted to clarify my question. In particular, since you did mention the Dragonstone substrates, is there resources to go look into some of those? What the work is on that and where it is in terms of its status, how far?
Well, most of things are already there. As I have said, that McCLIM specification is substrated design. Okay. And when you will look into McCLIM source code, you will see under core directory McCLIM Basic and McCLIM Core. So this lower level abstraction is put in McCLIM Basic and in different directory backends. It is just a matter of wrapping up a system, doing some cleanup, but it is already there and it is documented because windowing substrate, drawing substrate, medium substrate, these 3 components go into Dragonstone.
Okay.
And the rest goes into high-level abstraction.
Okay. Thank you. What was the other? So right now you mentioned that streams. So are streams not thread safe at the current moment? Like, and until that gets added in, because I noticed you mentioned it in your roadmap. Do you suggest like trying to separate like the back end operations if you need multi-threading from actually informing the application?
Stream operations are not safe if you call them from outside CLIM loop, but I will share my screen again. Share screen. Entire. Okay. CLIM listener. Is ordinary REPL which you can use. And here all stream operations are safe because it runs inside McCLIM loop. So you may write your whole IDE in McCLIM and then all operations will be thread safe. Standard output. And regarding asynchronous access, investigating what needs to be changed took some time, but fixing it is a matter of a few months. Stream operations will be thread safe by means of when you call an operation on stream, it will just see if it is CLIM processing loop, and if it is not, it will just queue event, and event queue is totally thread safe. So you may execute commands asynchronously in for McCLIM from console or from Slime, and stream operations like draw rectangle will be also thread safe quite soon. But right now you may do it from Slime, and it will work like 90% of times, but you may corrupt the output record hierarchy.
Okay, so you're saying that from within CLIM itself, you're okay. But yes, the interaction between the two is the problem. Okay.
Yes, and you may asynchronously signal events for it.
Okay.
So that's also not a problem because our queue is thread safe as well.
Okay. All right, that makes more sense. Okay, thank you.
Can you give me a explanation of the exact difference between window, pane, sheet, and stream? Because those terms all get used all over the place somewhat interchangeably, but I'd like to...
Okay. Show class superclasses. Okay, so here you can see a graph of inheritance, but most of this looks complicated, but most of that are mixins. So let's focus from beginning. Sheet is a window. Okay, it's possible to represent window or a composite widget. So it is like X11 protocol window, actually.
Okay.
Pane is something on what you can draw So it is something like a canvas. Sheet also accepts input. So you have events which may be directed that somebody clicked a pointer over this sheet. Okay, and you can draw on a pane as a result of that. And streams inherit from basic pane. So streams are yet another abstraction level over it. So you have sheets, you have panes, and you have streams. Everything else is implementation detail. Okay.
Oh, so streams are the top level, and everything goes down from that.
Yes.
Okay.
This you can use basic panes to implement logic in your application. You remember this demo where I were moving over window and things were blinking with where I have resized window from the actually CLIM application.
Yes, I remember that.
Okay, then this window was which were blinking was basic pane, and it wasn't actually CLIM. It was using some lower level abstraction.
Okay.
So such gadgets, widgets could be implemented without concerning yourself with presentation, comments, this whole abstraction, which is really useful, but quite complex.
Okay.
Wow.
Yeah. That's...
And I guess my other question then is, can you clear up redraw versus repaint versus redisplay for me?
Okay, redraw and repaint is the same. Okay.
Okay.
Displaying, you have your application. Okay,
right,
and you compute things. You query database. You take these records and you display them on the screen. So this is operation which costs a lot, resource-wise. But sometimes you want to, your window is overloaded with something else and you want to redraw it. So after displaying things, graphical objects get recorded. Presentations are also output records. So you have the semantic links between what is presented and data.
Jod, mute your microphone.
Yeah.
Did someone summon a demon?
Mute the microphone.
It's frustrating when we don't have an admin on the Hangouts. There's no one person who can actually mute other people.
Yeah.
Okay,
right.
So this is display. This is costful operation, and repainting or replaying is taking these output records and drawing things on the screen. So this is drawing on the screen is costful operation anyway. It is always costs a lot, but it is not as costful as displaying your application logic actually. So you may, in this display function, you compute things you want to put on the screen.
Sure.
Okay. So if you just want to draw stuff, you're saying just use repaint. But if you're doing anything more complex than that application-wise...
Well, my experience with the API is that you can, if I remember correctly, you can implement... I've only touched a little bit with the internals here, so I may totally stumble over my words. But if I remember correctly, you can override at least like basic pane and then override handle repaint on that.
Yes, and I will show you that in a second. Okay.
Sure.
In package theme user. I'm lazy again.
Sure.
We define class. My pane, which inherits from basic pane, which is not a stream.
So you can draw on it, but you can't like write strings to it. You can't
you can draw strings. There is an API. So we define two functions, two methods. Handle event, and client is my pane. Some event, and we may put here everything. Everything, by everything I mean something.
Sure. Yeah.
We'll have a counter. We will have a counter here. We define handle repaint. Client my pane. Region. Region tells us which part needs to be repainted, because we don't always need to repaint whole screen. And we will always repaint everything. By default, we align to baseline, but I want it to be centered.
Okay. We handle repaint.
And it doesn't work.
Did you set the default size on the pane?
No, the default.
Yeah. Yeah, let's try that, see what happens.
Did you compile the...
No,
it works.
Well, yeah, I mean...
It's displaying, so it's working, so...
Well, I mean, live coding.
Yeah.
Let's see.
Recompile the whole file, maybe?
I will just see what's going on here. Handle repaint. Yeah. Handle repaint. It should be that.
You handled the event, but you didn't actually register it, did you? I mean, or does it do that already for you when you override?
What?
Yeah, it's calling handle event every time. Just by being a pane that's part of the application, it's getting handle event.
Oh, okay, got it. Okay.
Okay, here we have. I will change the color.
Oh, does handle event call handle repaint? Normally.
No.
Okay.
When you have event repaint, then it is handled. There is separate protocol for that.
Okay, yeah.
Text size. Huge.
Yep, there we go.
Let's just put the number here. Okay. maybe we need to call actual handle demand handle repaint.
Where is it? Yeah.
Okay.
Yeah, there we go.
So this is our simple application, and you may build toolkits from here.
Sure.
That's it. Okay. Cool. That's actually pretty.
So
cool.
it is like, I don't know, 22 lines of code.
Yeah, that's really clean too.
Neat.
Yeah, neat. Really...
So like the regular application pane is using output recording to provide the handle repaint functionality, right?
Yes, and replaying is just going through this output records hierarchy and replaying them.
Okay.
And you can subclass everything and specialize every method. So
sure.
Actually, you may make things even faster by not recording things. Actually, I did that in one application, but creating dynamically output record hierarchy based on what you want to repaint.
Oh wow, that's
so
neat.
Does output recording mean that so you have a database of events and you can that's what's used to do the undo redo?
No, so it's well, I'm sure you can explain it better than I
can. Could you repeat?
Yeah,
the question?
I was just wondering. I'm not entirely sure I understand output recording, but my understanding of it is that it's basically keeping track of the state of the application through the series of user interactions, so that if you want to go and undo an action.
I will get into code a little.
Yeah, so output recording is every time you draw something on screen, it records that you drew something, and so every time it triggers a complete redisplay of the frame, it can record all of the things that were drawn.
Oh,
right. So yeah.
So here you have event queue, and it is just normal FIFO queue.
Okay.
It is thread safe, but regarding recording. This is some macrology, but generally this works like when you call draw rectangle, and if stream is recording output, then you have a round method over draw rectangle, and it creates instance of rectangle output record.
Okay.
Okay. So rectangle. So as you can see here, we have draw rectangle output record, and we record line style because it may not be filled inside. It may have dashes. You record other things as fact, whatever is filled or not, its coordinates, and when you replay it, you just output it back onto the medium.
Okay.
So this works like that. Medium, draw, rectangle are lower level methods which are implemented by backends. So when you write backend, you just implement these basic methods like medium, draw, rectangle, medium, draw, text.
Okay.
And so what that lets you do is in the handle repaint method, right? It lets you replay the output record without rerunning the entire application display logic, right?
Oh, okay.
Yes.
So
exactly.
Yeah.
Got it.
Also, presentations are. Yeah. Presentations are subclasses of output records. So when you put a presentation on a screen, it maintains a link between application and your screen, but it is also an output record which is simply replayed. So this is also worth knowing sometimes.
Yeah. So with our earlier example where the display function drew a rectangle. In a sense, CLIM remembers that you drew the rectangle, and it doesn't need to call your display function again just because the X server decided to lose your bits.
Gotcha.
The X server misplaced the bits of your window and said you needed to redraw those. McCLIM doesn't need to recall your whole display function just to satisfy that. It remembers you drew a rectangle there, and so it just repaints that rectangle.
So so he keeps track of what's been redrawn, what's been redisplayed, right. But it's not a full. I guess my question was whether it was a full-on record of the state of the application or not.
No, just what things have been drawn on screen.
Okay.
Mm-hmm.
Got it.
So here I will show you another thing. Let's draw it on standard output 42 and we just draw integer. But we will draw a rectangle which will be a presentation of type integer.
Okay.
It is ad hoc. As you can see, I didn't define present method. I'm just putting it in a code.
So this is like an alternative to making a present method for integers. For sort of a one-off thing.
Right.
And now I will call accept method. This is another presentation method. I didn't discuss it because I could go on for arbitrary amount of time with it.
Understood.
So I can type integer from the keyboard, but I can also select this rectangle, and I have 42.
Nice.
So
I like the fact that it overlays it too.
Is the basis for how the command processor is able to do things like accepting the ASDIF systems that we were looking at earlier. Right.
Okay.
When we were saying things like when you defined a command that took that takes an ASDIF system, the way it was able to make those clickable was using the accept infrastructure, right?
Maybe I will show you a failure mode. Oh, maybe not. I don't have text here. Never mind.
Very nice.
But yeah, it's an interesting system to say the least. And yeah, one of these days I'm going to get back into my explorations of accepting values and see if I can detangle that from how I expect it to work.
Yes, this is also worth noting that McCLIM is usable. You can create applications with it, but it has quite a lot of bugs, which we are fixing, of course, and it gets better every day. But it is not that bugs are uncommon. So this is something what needs development.
Oh, understood. Yeah. One thing I did notice, I didn't notice at least in the demos, and maybe I just missed it. Is there a notion of like progress bars or stuff in the predefined gadget set already available in McCLIM? So like if I want to...
Well, there's certainly sliders.
Yeah, I saw sliders, but
there are predefined gadgets. I will show them to you. Regarding progress bar, there is none, but it may be easily written. So,
okay.
I'm working on making gadgets easier to intermix them with streams, because right now gadgets work on top of a handle event loop, and streams actually hog on the event queue, so you can't mix them well.
Got it.
That's something I'm working on right now, so this will be fixed very soon. So these are gadgets which work.
Right.
So those are more or less just panes that have a handle repaint that looks like a button or a checkbox or something, right?
Mm-hmm.
So you could in principle define your own gadget that draws a progress bar, using some rectangles and draw text.
Yeah, and then write the handle.
This is actually, this may be, it doesn't subclass gadget, but it is some kind of widget you can use.
Yeah, in principle, you could make that subclass gadget and have it handle a few extra bits of the gadget protocol, and then you could just use it like a gadget, right?
Mm-hmm.
It wouldn't be, something that a backend would know how to give you a native gadget for, but it would do the job.
Certainly. That's a nice graph.
Hey, you've been doing some graphing stuff, haven't you? I remember hearing you talk about that on the IRC occasionally.
Well, I'm working on library which is inspired by ggplot2 from R. So I have a prototype, but I don't have API finalized. But I want I want to have a complete system. I'm usually working on 5 or 6 things at the same time, so I never know when the things get finished. So I'm just pushing out screenshots.
Yeah, it looks nice.
Very nice.
Let's see if I have it here. I do, but as you can see, it doesn't load at the moment.
Always fun when systems don't load.
Well, that's because I've made some changes which were working, and it is not even committed stuff which is there, so never mind.
Yeah, that's how it always goes.
Right. Now, in terms of and I hate to bring up the backend question again, but this is in terms of the backends that are already available when you download McCLIM right now. I noticed that there was a demo for not just for CLX. There was one for frame buffers, I think it was.
The X11 frame buffer one.
Yeah, the X11 frame buffer one.
As you could here we have
right there. Yeah.
Frame buffer backend.
Right.
And it works. It is a little its performance is a little worse, but we want to extend it so it works as well as possible. So it is possible. So we can compare backend on the system, and this reference look and feel. Let's see. We can create here side by side view.
Yeah. And
this is drawn with our backend, X11, and this is this frame buffer backend.
Oh, nice.
So as you can see, here we have anti-aliasing.
Looks eerily familiar.
That's really good.
So
the reason I bring it up is because that would be very useful. I started playing around with more stuff with my Pi recently again, and I was curious if I think McCLIM works with ECL, so in theory I could use ECL plus McCLIM to actually write a simple application on my Pi with the frame buffer, but I don't know how far that would work.
Not directly against the kernel frame buffer.
Yeah.
It works with X11, but you could create direct frame buffer backend. Right. Sure. Regarding ECL, I'm maintaining ECL, by the way. So it works, but it doesn't work at the moment because we exited. J substrate has gained few new keyword arguments, and ECL has a bug with applying from stack frame when you exceed maximum C argument number limit. So I'm working on it right now. I have even buffer opened with it, so it should land in develop branch soon.
Okay.
But at the moment, it may have problems with running.
Okay, got it.
Of course, hacking it to work shouldn't be a big problem because it is enough to comment out a few init args. But if it doesn't work for you and you try it, just drop me a line and I will give you a one-liner which will make it work. Okay.
Okay.
But it will just hide the underlying issue.
Got it. And Elijah, Elijah, I was just bringing up the frame buffer thing because Qt kind of does the same thing right now. I think on the Pi.
It can write directly to the kernel frame buffer.
I think it's either the kernel frame buffer or at the very least the X11 one that goes behind the scenes. I know that you could with Qt embedded, you could compile it down to something where you don't necessarily need. You only need the bare Linux kernel in order for it to actually run.
Yeah. So that would be talking to the kernel frame buffer.
Yeah. So.
Yeah.
It's. I was just
Direct
curious.
Rendering interface. Hooray!
It would work. It's kind of useful.
Bits straight to the graphics card.
Well, it's useful for the embedded systems case, right? Because you're minimizing.
Yeah. I mean, it's useful for the case of people that don't want to use X11.
You're right. Exactly. What's the?
Oh, that looks nice.
That's really.
I'm working on drag and drop to make it work better, but this is nice indeed. There are a few bugs which I work on at the moment. Never mind that.
And finally, I didn't see. I saw an example of the 3D cube that you showed earlier.
No, this is a hack. There is no 3D in Mac.
Yeah,
there is no. 3D
you can. Okay. What could be supported, and we want to support it, is to have a pane which allows you to embed OpenGL context.
Okay.
But then you will be programming in OpenGL, and it will be capable to embed it in a CLIM application. But there is absolutely no abstraction to manipulate in three-dimensional space.
Okay.
Okay.
All right.
This is a very cool hack. I very like it, but it is nothing more.
Too.
It is a hack. All right, got it. So you're simulating 3D there. You're not actually getting a hardware context here.
Yes, and I'm showing a lot of stuff, but most of it was developed by someone else. I'm fixing some of the bugs, but it is a system which is developed for 20 years, and I have joined like 3 or 4 years ago. So my contributions are really small compared to contributions of other people which worked on the product in the past.
You're keeping it going, so, you know.
Yes, certainly. And hopefully...
Yes, I'm very proud of what I'm doing, but I'm just saying that
sure.
Don't take everything what I show you as something I did.
Okay.
I didn't touch Logic Cube, for instance. So.
Got it. All right. Okay. Cool. Any other questions from other people in the in the chat? All right.
Sorry, I'm looking at IRC, but I will stop screen sharing. You will see my secrets.
Certainly. Yeah. And there doesn't seem to be anyone asking.
3B was actually just suggesting a glop backend for McCLIM as a way of testing glop's ability to do stuff on the same level as SDL2. It's an OpenGL. It's a platform interface that's written in pure CL with the idea of getting just you enough to get a GL context.
Actually, 3B has abandoned glop and is now working on glop 2.
Oh yeah, that's right, glop 2. Yes, sorry.
Okay.
But yes, glop 2. Yeah, but the idea is it's just it's similar to SDL2. It basically it's just enough to get an event loop and a window on screen and that kind of stuff. But in pure CL, you know.
Nice.
Yeah.
So that could be a good basis for moving forward. Although SEL2 works on multiple platforms, right? So.
I'm fairly confident that the CL, like about a quarter of the code in the CLDK backend could be just taken out of there, pulled into its own little code base, cleaned up a little, and made to work again. Because it was working before. I've used it for things, but sometime back in November or something, there was a big refactor of the backend APIs, and all of a sudden it's broken now.
We are in constant refactor, so only stick to specification and do not depend on internals.
Right.
I'm sure. Yeah. I'm sure that even since I looked at it, there's now at least another half dozen things that have changed that I need to fix still.
Right now, for instance, I'm changing the event queue. So
right, right.
So if it is documented as in specification or as extension, sure, use it. But if it is not, you're on your own.
Oh, so in the specification, if it says extension, we're good. If it doesn't say...
Well, the specification doesn't have any official extensions that I know of, but McCLIM actually has documentation on its extensions, right?
Yes, so we have some documented extensions.
Okay.
In McCLIM, in the catalog directory documentation, you have a specification, you have documentation. So.
Okay, cool. All right. Well, thank you so much.
Documentation is not complete, so you may be disappointed with what is there. There is some stuff, but not everything.
Well, making a lot of progress, though.
Yeah.
I'm glad to see another big Common Lisp project make moves again.
Yeah, absolutely. I'm excited. I mean, especially McCLIM. I at one point started writing applications in McCLIM way back when. Then I cut off from it to learn more core CL since I was behind and actually really understanding core CL. So now,
as I said, learning CLIM is hard because you don't have good documentation. It's like learning Common Lisp object system by reading out of a meta-object protocol.
Right.
Well, you can learn CLOS that way, but I wouldn't recommend it.
Right, absolutely. I looked at the tutorial again and started going through it that way. I'm hoping that that's probably the right move, the PDF that was on the McCLIM website.
If you want to write something and you are stuck, just join CLIM channel. It is active and people actually try to help each other. So response time is really short, and that's the way to go.
Great. That's great. All right. Oh, man. So thank you, Daniel, for your great overview of McCLIM. I mean, I'm hoping this is useful for folks to go in and get them excited to write CLIM applications. For those of you who are waiting for the Windows backend, I say, for the time being, install Xming and write your application, and then hopefully we'll get a Windows backend and maybe other backends also going in, so that.
Well, in this extended PDF which you saw, there is a link to alpha quality Windows backend which works natively on Windows. It is not part of McCLIM repository, and development is actually no more. Nobody works on it, but it's a good base. If somebody is interested enough in making McCLIM work natively on Windows, to extend it and make it work.
Yeah. And
if not, then they will have to wait for SDL2 backends.
Yeah, SDL2 at the bare minimum, even Qt at the bare minimum if you really wanted to at some point. Yeah, but yeah, and I say just start writing applications, and hopefully send bug reports onto the ROC channel. And is there
nice bug reports with good reproducible examples? And,
yes,
please.
Yes, there is a track on GitHub, so if you hit bugs, just put them there, and that's
right. So until next time, guys, I hope you guys had a great like this talk. Please submit ideas to us on Discord and IRC. We're on both the IRC Freenode channel
and even on the functional programming Slack occasionally.
And the functional programming Slack. I tend to squat in there, but certainly there are many avenues for you guys to submit talks and ideas. We're looking forward to hearing and hopefully highlighting more Lisp libraries that are just actively being developed to create awesome Lisp applications. So,
do we have a plan for next week?
Not at the current moment, but I will.
I mean, we can always, revert back to our keep progressing through let over lambda now.
Yeah, our next one is going to be on on Lisp efficiency anyway. So that's chapter 7.
Sure.
So tentatively, I'm going to say we're going to be going through Chapter 7 on Lisp efficiency, but if I come up with another idea before then, I will certainly announce it before
cool.
then, if that makes any sense for anybody else. So
yep.
Until next time, I'll see you guys later. Thank you
Bye,
again.
everyone. Yeah.
Bye.